How many phones have you owned? When was the last time you bought a new computer? A new TV? Is keeping up with the newest Apple product one of your top priorities? The newest Android product? Do you keep track of all the TVs, computer monitors, printers, scanners, keyboards, mice, cables, circuit boards, phones, answering machines, digital/video cameras, lamps, clocks, flashlights, calculators, radios, VCRs, DVD players, MP3 and CD players that you have bought, used, and are now going to throw away? I'm asking because one of the biggest environmental threats in this current modern age is electronic waste, which is defined by Merriam-Webster Dictionary as, quote, waste consisting of discarded electronic products. Prior to the 1970s, very few places in the world had regulations pertaining to discarding hazardous e-waste, so dumping into landfills was a very common practice. However, as time progressed, many developed countries, such as the United States and Europe, began to regulate how hazardous e-waste was managed. To comply with these regulations, companies had to spend more time, money, and resources to dispose of the e-waste properly, which is not something they wanted to do. So, what happened next? Well, to comply with these stricter regulations, many hazardous e-waste producing businesses began to look for alternatives as to how to dispose of the waste at a lower cost. One such method was filing for approval to export their e-waste to developing countries, such as China, India, Pakistan, and Nigeria, which all had weak regulations. These countries see the economic incentives and fail to acknowledge the negative environmental side effects that are caused by e-waste. Although there are still regulations, shippers found a way to get around the system. For example, boxes were often mislabeled with names incorrectly classifying the e-waste. Now, piles and piles of mobile phones, laptops, and other electronic devices are collecting in landfills around the developing world. And it doesn't seem like this incessant stream of waste is bound to end. Over the last 4 years, the dumping of electronics has increased by 33%. In fact, the weight of this e-waste equals 8 of the 10 Egyptian pyramids. In 2014, nearly 50 million tons of e-waste was generated worldwide. That's 7 kilograms for every person on the planet. You may be asking, well, what's the big deal anyways? Can you give us a list of the environmental impacts of e-waste and the human health impacts?
Well, if you want to start at the beginning from where things are mined, and we just take gold as an example because there's micro-thin amounts of gold in circuit boards to make them better conductors. Mm-hmm. So if you start all the way at the beginning of the process and say, what are the impacts on human health from mining? There could be some downstream impacts, everything from the potential harm to the, let's call it the garbage man who picks it up, picks up that big heavy TV. It's got glass, it drops, so there's immediate potential impacts. And then kind of the ones that a lot of people think about when some scavenger is taking it apart to get the copper out of the back of that older TV, because there's a fair amount of copper wire in what's called the yoke of the TV, so he's scavenging that. He could cut his hand, and then if he's getting a wire with insulation on it, a lot of old school, you used to see this in electricians in their backyard, burning off the insulation off the wire. So a lot of the insulation is made with vinyl chlorides, and you really don't want to burn vinyl chlorides. They're precursors to dioxin, for example. So you could extrapolate that kind of, let's call it low-tech scavenging and extraction of materials from e-waste all the way to smashing open with a hammer to get out a little bit of circuit board that you could sell for a few bucks. So there's immediate physical hazards of all those activities, and then further downstream, the thing that people contemplate is if the stuff goes to a landfill, let's say a TV with leaded glass, and then eventually the TV is crushed and there's little particles of leaded glass, and eventually enough acidic leachate, the garbage tea, leaches out some of the lead, and eventually it breaches the liner in the landfill, and eventually it reaches the water supply, and eventually it poisons somebody. But that's, from my perspective, that's minimal compared to what, all the way back upstream at the mine, and all the way along the value chain where potential hazards could be. There's some concern that if electronic waste go overseas to less careful disposal points, that the same kind of thing happens that I talked about. They're burning the wire, they're smashing it open, the unwanted part is going in the nearby water supply, and there's more direct potential for pollution from that. But as far as, you know, being able to document that and quantify the amount of health damage from me throwing a TV illegally into an export market, it's harder to quantify and document that.
Electronic goods contain toxic substances such as lead, mercury, cadmium, arsenic, flame retardants. Once in a landfill, the toxic materials seep into the environment, contaminate the land, water, and the air. Toxic chemicals such as lead, cadmium, nickel, and lithium were found in the soil at e-waste recycling sites in the Philippines. These chemicals can easily leach out into local water sources, find their way in food, and can easily be transported by the wind. Other ways that chemicals are being released into the environment is by burning, burying, or dumping. 3 common disposal methods include landfills, melting components, incineration. These can make their way into groundwater, which creates water pollution problems for nearby ecosystems. Mercury, which is found in thermostats and fluorescent bulbs, bioaccumulates in wildlife, especially fish. While some fish are safe to eat, most become toxic to the point where consuming them can lead to death. In terms of human health effects, the workers who disassemble shipped-in e-waste are the most at risk. China employs over 150,000 people. These workers lack the proper equipment and are exposed to toxic concentrations of many harmful chemicals. So what's the best way to deal with the growing e-waste problem?
Hello everyone, we are here at the Solid Waste Orange Community Recycling Center to speak to Blair Pullock, who's in charge of solid waste and recycling programs. Let's go inside.
Hi Maddie, I'm Blair Pullock, the Orange County Solid Waste Planner.
Hello, nice to meet you. I'm Maddie, I'm the level trainer at APES. Blair L. Pollock is Solid Waste Planner for Orange County, North Carolina. He initiated public recycling programs in Orange County beginning in 1987. Mr. Pollock was a founding member of the Carolina Recycling Association. He is a national trainer for recycling managers for the Solid Waste Association of North America. He holds a master's degree in city and regional planning from UNC Chapel Hill. Mr. Pollock was gracious enough to give us a tour of the solid waste facility, explaining the process of electronic waste recycling along the way.
Aside from your living room, this is the first stop.
Each item's journey through the recycling center is recorded so that its final destination at each step along the way can be accounted for and tracked. All storage media is either shredded or undergoes an intensive data erasure procedure. OCSWRC is compliant with NIST 888 guidelines for media destruction. They take seriously their data liability and use certified data erasure software, military grade, for wiping all traces of data from the hard drives. Tagged equipment is then tested, since computers and electronics are made up of many different components. Working parts and systems are identified and then tagged for reuse or refurbishment. Reusing working electronics helps preserve our natural resources by avoiding mining of virgin materials and helps reduce the air and water pollution that is generated during manufacturing processes. Equipment that is non-functional or totally obsolete is marked for dismantling. Here, all circuit boards, batteries, and other components containing potentially hazardous materials are removed and sent to qualified domestic refineries to be further processed. Air quality and worker safety are carefully monitored in each dismantling area. Each item is safely disassembled into its basic components like plastic, steel, aluminum, and other materials which are sent to approved refineries. There, they are melted down or processed so that they can flow back into the production chain. OCSWRC manages all assets, weighing and tracking them to their final disposition. Reselling and finding new uses for end-of-life electronics can make technology accessible for those who otherwise could not afford it, as well as defray some of the costs of breaking down the raw materials for recycling. We also went for a thrill ride up the landfill and got to see the methane capture system and stand on top of 20 years of Orange County waste. Mr. Pollock informed us that municipal solid waste landfills are the third largest source of human-related methane emissions in the United States. At the same time, methane emissions from landfills represent a lost opportunity to capture and use a significant energy resource. However, the Orange County landfill collects the methane and uses it as an energy source. Since we were already there, Mr. Pollock also took us to see where construction materials, yard waste, oyster shells, tires, mattresses, etc. collected to be recycled. After the tour, we came back to the office to ask Blair a few questions.
What would your advice be to people in our classes who might have a lot of old phones or computers that they'd like to dispose of? What would be the first step in doing so?
It really depends. You want to not lump everything together. So if you've got a phone that's still functional but it's outdated or what have you, your best first step might be to find out if there's any kind of trade value for that, etc., and see if they'll give you some money back on your new phone, and then they'll properly manage it. You should also go through some data wiping protocols so they don't end up with your phone list and all of your friends' photographs and all that. And most of the companies now have a data wiping protocol.
And in terms of like economic viability, is the e-waste program here, is that, like, what is that funded by? And
the e-waste collection in Orange County that the county does is funded by a combination of some money from the state that came through the sellers of computers and televisions. They're obligated by state law to contribute to a fund that we have as a local government that collects electronics. We have access to that fund based on our population and how many tons of electronics we recover.
so once Orange County Solid Waste Recycling Center ships out the e-waste to any of the numerous registered electronic recyclers in North Carolina, what happens?
After collection and transportation, materials in the e-waste stream must be processed and separated into clean commodities that can be used to make new products. Efficient separation of materials is the foundation of electronics recycling. Initial shredding of e-waste stream facilitates sorting and separation of plastics from metals and internal circuitry. So, e-waste items are shredded into pieces as small as 100 millimeters to prepare for further sorting. A powerful overhead magnet separates iron and steel from the waste stream on the conveyor. The separated steel materials are then prepared for sale as recycled steel. Further mechanical processing separates aluminum, copper, and circuit boards from the material stream, which now is mostly plastic. Then, a water separation technology is used to separate glass from plastics. Visual inspection and hand sorting improve the quality of extracted materials. The separated streams of aluminum, copper, and circuit boards are collected and prepared for sale as recycled commodity materials. Advanced separation technologies are used in the process. The final step in the separation process locates and extracts any remaining metal remnants from the plastics to further purify the stream. Preparation for sale as recycled materials. After the shredding, sorting, and separation stages have been executed, the separated materials are prepared for sale as usable raw materials for the production of new electronics or other products.
Mr. Pollock gave us an invoice of the weight of all the electronic items they had harvested from civilians and how much they had sold the items for. Some of the notable items were 1,058 pounds of cathode ray tube monitors, which sold for $270.08, 5,374 pounds of televisions, which sold for $1,504.72, and 529 pounds of LCD, which stands for liquid crystal display monitors, which sold for $79.35. As Pollock said during the interview, the profit made from selling these old parts helps keep the whole recycling operation going. Hopefully, this video has taught you something new about e-waste, such as what it is, the associated negative environmental and health impacts, and how we deal with this stuff right here at home. My last piece of advice is to only buy that new electronic gadget if you absolutely need it. And to get rid of your old electronic gadgets, remember to bring them to the Orange County Solid Waste Recycling Center. They'll take good care of it for you. Thank you so much for watching this video.